Hi everyone, so next the 10.C, Macaulay duration and price sensitivity. So this is more theoretical section. So we prove a theorem. So we have seen that the duration is roughly proportional to price sensitivity. But we want to just formulate this mathematically. So we remember the two different quantities. So first one, the present value of a bond. So if we have the cash flow a sub t at time t, then p is given by the summation of at times the v to the power t. Maybe we can put the index I, but we can just drop it for now. And how about the formula for Macaulay duration? So Mach d was defined by, actually the denominator is p, so summation of at vt, and the numerator is the t times a sub t times v to the t's power. Okay. So now we want to derive the something about Mach d, and we want to show price sensitivity. Duration represents the price sensitivity, and actually we have a kind of beautiful theorem, and Mach d is actually equal to negative of price sensitivity d delta p over p. Here delta is interest, and actually this is not really I, but the delta is equal to force of interest. So delta is equal to log of 1 plus I. So remember that the log of 1 plus I is almost equal to I. You can just see the logarithm function. So this is force of interest. Okay, so what that means? So we think about the price and the derivative of price. So this is basically the rate of change. And if interest rate goes up, then actually the rate of change in price is equal to Macaulay duration with this negative sign. Okay, so remember that the interest rate goes up, then delta goes up, then actually the price goes down, right? So we have to have negative sign. So yeah, so price goes up, then price goes up, then interest goes down. Interest goes down, price goes up. So we have to have negative sign. And actually this is equal to Macaulay duration. So in this sense, we don't have I but delta. But if we use delta as an interest rate, Macaulay duration is exactly the measure of price sensitivity. So what's the proof? How to prove it? This isn't really too difficult. So what's the Macaulay duration? What's the price sensitivity? So we start with the right hand side. Okay, so right hand side. So right hand side, we just write down everything. So right hand side, we have to just plug in this p here. So okay, so negative, we have negative sign. So negative of the d delta of summation of a sub t vt, okay, and the p is summation of at vt. So here, okay. Then what to do? What is v? So v is equal to 1 plus I. Right, so that is equal to e to the power log of 1 plus I. So this is e to the power delta. So that means the numerator is, okay, so still negative sign. Numerator is d delta summation at e to the power delta t. And the numerator, denominator is just the same, so summation of at vt. So v is actually the negative, so 1 plus I negative 1, so this is negative and this is negative, so delta we have negative. Okay, so then we can differentiate with respect to delta. So delta we want to differentiate with respect to delta. Then this is exponential function, so this t so comes before the exponential function. So actually this becomes a negative t. So summation of at times negative e to the power negative delta t. Okay, then we have still negative sign here, Then denominator, this is just at times vt, but we rewrite vt, so vt is e to the power negative delta t. Okay, so now what happens? Oh, sorry, we have negative t here, so negative t. So this becomes, okay, so at first the negative sign cancel here and here. Then only the difference in numerator and the denominator is t. So you can see that this becomes summation of t at, and again we go back to vt, and summation of at vt. So this is exactly the definition of Macaulay duration. So this is equal to Mach d. So this is the end of the proof. Okay, so now we prove that Macaulay d is the price sensitivity if we use this force of interest instead of I. Yeah, so this is the chapter 10.c. So just I want to review quickly explain the 10.d. So the textbook defines the modified duration. So that is basically to adjust this delta and I. So it's a little bit unnatural to introduce delta instead of differentiate with respect to I. So modified duration basically modifies that definition and to have the simpler, more beautiful formula. Okay, so that is 10.c. Yeah, and the 10.c is theoretical section, and we don't have any exercise questions to prove this kind of theorems. Okay, see you then.